Merci de votre invitation. Je ne parle pas beaucoup de français, donc je vais continuer en anglais. Cependant, n'hésitez pas de me poser des questions, mais en anglais, s'il vous plaît. Okay. I'd like to start just by introducing myself. I am Technical Director of Crop Protection in ADAS, and I'm based in the west of England, near to Wales. And this image is actually just a picture from one of our field trial sites in 2021. This is looking at winter wheat and the disease Septoria tritici, and you can see various squares of green and brown within this field. This is what our fields look like in late June and early July, with very high levels of Septoria tritici. Just to start by introducing the company that I work with, ADAS, you may not have heard of us, but we used to be a part of the government. We were in the government until the 1990s as a part of the Ministry of Agriculture and Food and Fisheries. We were privatized in the late 1990s by the Conservative government of the time, and have since 2016 been part of RSK Group. As ADAS, we have around 350 staff, and essentially we provide independent research and consultancy to government, to farmers, and to chemical companies. That independence is very important to us, and we use that research to provide technical support to agronomists and growers. If you were to look for an equivalent organization in France, I don't think there is one that is exactly the same, but Arvalis probably becomes the closest that you have. In the UK, there are a number of diseases that cause problems in wheat. Of all of the pictures here, the one on the left is the biggest problem. Septoria tritici affects nearly all varieties in most years. Yellow rust, brown rust, fusarium, and powdery mildew are particular problems of certain varieties, and in certain seasons can be quite troublesome, but generally it is Septoria tritici that drives our fungicide programs. And what difference does that make? Well, when we look at the yield response that we get in trials and in fields, we on average see a yield response of around 2 tons per hectare, sometimes a little bit more than that. It varies enormously from one season to the next. For example, in 2010, we had a yield response across all varieties. The average yield response was less than 0.5 ton per hectare. But in recent years, the prevalence of Septoria and the prevalence of yellow rust a bit as well has meant our yield responses have been quite large. In 2021, I think it was around the average around 2 to 2.5 tons per hectare. When we think about disease management in wheat, disease management to just control the disease is perhaps the wrong way of looking at it. We should instead look at what we are trying to protect. The key yield forming period in wheat is between the crop flowering and the crop senescing, usually between the middle of June and the end of July. During that period, we rely on the top 3 leaves and the ear to intercept light and convert that into sugars and starch. It is those top leaves that are absolutely critical to yield, and that is what we are aiming our fungicides at. And in the UK, that means that we think about fungicides on 3 or 4 occasions. And these are the timings that will generally be seen in the UK. The most important of these are in the middle, and the T2 around growth stage 39, the point at which the final flag leaf has emerged, is the most important timing that we have. At that point, you have the 2 yield leaves that have the biggest impact on yield have just recently emerged. Second to that, the T1 timing at growth stage 32 is considered very important to slow the epidemic down and prevent disease development onto the upper leaves. The T0, that is, again, more about slowing the epidemic and has less impact on yield than the T1 or the T2, but can be an important part of a strategy, especially on more susceptible varieties and in higher pressure situations. And the T3 is all about fungal diseases of the ear, the fusariums and microdochiums. Just wanted to touch on how we control disease now, and the fungicide performance study covers some of the aspects on how products are changing, how efficacy is changing. And this just shows what we have seen in terms of efficacy from the azoles. The azoles have been a very important group for us over the years, and we have seen a gradual decline in the activity of key triazole fungicides, key DMI fungicides. This just shows how the decline has occurred. In 2001 and 2002, we were getting 80 to 100% control in a protectant situation from a full label rate of an azole. Now, we're getting closer to 20 to 30% control. You'll note that there is one new colour on there. There is a new azole in the UK, which thankfully is, for now at least, producing much better control, and that is performing similarly to what we were seeing from other azoles 10 or 15 years ago. But the problem that we have is the more we apply fungicides, the more we select for insensitivity. Now, I'm not sure if you are familiar with these charts, but here each line represents an individual year, and each point on that line represents an individual isolate of septoria. There are thousands of isolates of septoria out there, millions in fact, each with slightly different profiles and slightly different sensitivities to fungicides. The problem we have with azoles is that the line is gradually shifting further and further to the right. In other words, the population is becoming less and less sensitive to the azoles we apply. And you can see even in 2021, we were seeing further shifts in part of that population. It was moving a little bit further to the right, becoming a little bit less sensitive to the fungicide. With SDHIs in the UK, we're seeing a similar sort of decline. The graph is slightly different here. This is again looking at percent control. Here, the black lines, the thick black line in the center of each graph represents the average percent control from a number of trials in that year. The dotted lines represent the highest and lowest level of control. This was within the AHDB fungicide performance trials. There are usually between 6 and 8 trials within each season. If you look at the black line, you'll notice we see a bit of variation from one season to the next, but there is clearly a general trend. In 2016, we were seeing between 75 to 85% control from a half or a full label rate of an SDHI. If you look at 2021, we were seeing between 30 and 40% control from a half or a full label rate of an SDHI. That decline is worrying and clearly indicates that these products are not providing the level of control that they once were. And it's supported by what we've seen in terms of SDHI insensitivity in laboratory tests. In 2003 and in 2013, we had a very sensitive population. The lines in blue and green on the left clearly show quite similar levels of EC50 values. But since then, there's been a gradual move further and further to the right. And to the point now where in the last 2 or 3 years, the current SDHIs available in the UK are really showing quite a high level of insensitivity, and some isolates up at the top here really very insensitive to SDHIs. Partly due to the fact we've been applying them generally twice within the UK in the last 4 or 5 years. Thankfully, to some degree, the SDHI azole combinations have been holding up quite well. That's partly due to them being relying on a new azole and the introduction of a new QII fungicide in the UK, allowing us to see efficacy at quite a high level still. But the 2020 graph is slightly concerning in that, if anything, I think the line is becoming straighter and we're seeing benefit in applying higher doses. That's an early indicator that we might be seeing a change in sensitivity. I just wanted to say a little bit about resistance now, because we've done quite a lot of work on this in the past. This is actually a piece of AHDB or government-funded work that was co-funded as well by a number of ag-chem organisations. The reason why it was co-funded by those, including Adama, is it's in everybody's interests that we maintain fungicides for as long as possible. Resistance comes at a cost for the grower and for the companies. I'm not going to share all of the work from this because it would take far too long, but I do have 1 or 2 slides that just show, or 1 or 2 graphs that show what we've seen. On the left-hand side here, the graph indicates, as you will see along the x-axis, an increase in dose. And one of the clear findings in this study was that as we increase the dose of SDHI, we actually increase the selection for insensitive isolates. The percentage mutant frequency increases. Now, some people struggle with that, but the truth is the more we apply fungicides, the more higher the dose rate, the more resistance we induce, the more resistance we get in the population. The second graph on the right-hand side shows it's not just about dose. Also, the more applications we make, the more we expose the pathogen to the fungicide, the more the pathogen selects for insensitivity. And we see just the same process. If we have 1 application, we increase the frequency from 35 to 45. If we had 2 applications, it went up again to nearer 60% of the population having certain mutant frequencies. So clearly dose and application number increase the selection. How do we therefore maintain control without selecting? Well, the key to that is to use products that aren't selected for. And that is why our fungicide advice in the UK always starts with choosing products that have a low risk of insensitivity or resistance development. So the multi-sites have been a very important part of our program, and that is the first part of our building blocks for a fungicide program. The next would be to use azoles, and the next after that would be to use SDHIs or new chemistry. And in new chemistry, I would include the QII fungicides that I mentioned a moment ago. This actually supports other work that's been done. This was actually a research review by two of my colleagues, Frank van den Bosch and Neil Pavley. In 2014, they reviewed hundreds of papers looking at resistance and found that of the research that had been done, various different approaches had been taken to see which strategies either increased selection for insensitivity, had no effect, or decreased selection. And of all the papers they reviewed, they found, of the 19 papers they found looking at dose, that 16 found that an increase in dose increased selection. So exactly what we saw in the piece of work I have just shared with you. Increasing the spray number of the 6 studies, all 6 of them also showed an increase in selection from that approach. Splitting the dose, now instead of applying it once, applying it twice, that also seemed to have generally a negative effect. You're exposing a pathogen to the fungicide for a longer period of time, so that is logical. The one clear factor that always seemed to decrease selection was adding a mixture partner. So adding a multi-site or adding a different mode of action will decrease the selection for a specific mode of action. There's some mixed evidence regarding alternation and adjusting timings. There may be some things we can do there, but the biggest factor there is adding a mixture partner with a different mode of action. That's probably enough on resistance. I wanted to touch on what we have seen in terms of activity from Volpel in terms of trials that we have done in the UK. One of the questions that is often asked here by farmers and agronomists is, okay, I might want to use Volpet, but is it going to be more profitable than increasing the rate of the SDHI azole? Why should I not just increase the rate? And so we actually designed a trial in 2020 to look at that very question. This is the trial site that we had. It was in the south of Herefordshire, as shown on the map. And actually, that is an aerial image of the trial being combined. What have we seen from Volpet? In terms of efficacy, I should just say that this is from the fungicide performance. We do find we generally get around about 40 or 50% controlled in the protectant scenario. And the dose response generally, here we can apply a litre to the hectare. So 1.5 litres to the hectare is our full dose rate. But we generally find a litre is a good rate to include. We'll probably be seeing most of the benefit from applying a litre. In terms of efficacy within the trial I mentioned, though, this was the information that we gathered from that data. On the left-hand side here, this is simply a chart showing the amount of septoria on leaf 2 and 3 at a particular point in time, and how that changes with dose of the SDHI azole. The blue line here is where we just applied a particular SDHI azole. I've called it SDHI azole 1 because there is another newer SDHI that was used also within this trial, and we will look at the results from that shortly. Here you can see, though, the dotted line is higher than the green line, which clearly indicates that we were seeing a disease control advantage from including Volpel. In this case, we applied Volpel in their T1 and T2 at 1.5 litres to the hectare. We can look at that a different way around and say, for a given spend, for a cost, which was giving us a higher level of control? Well, effectively all I have done is change the x-axis here to a cost axis. And when you consider it this way, clearly for a given spend, often at T1 or T2, a farmer in the UK will spend somewhere between 30 and 45 or 50 pounds a hectare. In that range, we were clearly seeing a benefit in terms of control of septoria from that application. And that was equivalent to around about 10 or 20%. When we look at yield, which is the critical comparator, you can see that we were also seeing a yield advantage. Here, the yield advantage, depending on exactly the point of comparison, in terms of SDHI rate, varied from 0.4 of a tonne to about 0.2 of a tonne. But clearly, that was advantageous. What did that mean in terms of the economics of growing the crop? Then that's the important factor. Well, we did also look at what we call here the margin over fungicide cost, MOFC. And so that is simply the output in terms of the yield of the crop times by the price of the crop minus the cost of the fungicides. And clearly the output is changing with SDHI dose. So we simply graph that in that way. And you can see the highest margin here was quite clearly achieved with the inclusion of Folpet. Now the prices we've assumed here, we've assumed a wheat price of 165 tonnes per hectare, pounds per tonne rather. Now that I think is, if anything, is quite modest compared to where the price is now. I think it's considerably above that at the moment. As I said, we did also look at a second SDHI azole, and that is what is shown here. We've got the dotted line representing, this is a better SDHI azole. It was working to giving us more control. But even over that more effective SDHI azole, we were still seeing a very clear benefit from including Folpet at 1.5 litres to the hectare. And when we look at the percent control by cost of application chart, exactly the same benefit coming through, a clear benefit in terms of percent control. So I think it's quite clear in my mind from that that you can't just increase the dose of the SDHI azole and expect to achieve the same amount of control than you would get from actually using a slightly lower rate of the SDHI azole and a different mode of action, a multi-site. That's not the only work we've done. We looked at this in 2021 as well. And in 2021, we had quite a high pressure of disease. This was a trial near Hereford where I work. And you can see on, this was an assessment in early July. And you can see clearly that the untreated had just over 5% disease on the flag leaf at that time, and approaching 40% on leaf 2, so quite a high level of infection. The SDHI azole itself at that point was doing quite a reasonable job. It was reducing the amount of septoria on leaf 2 to around 15%, which was good. But you can see, though perhaps not quite statistically significant, that adding Folpel at 0.75 a litre or 1.5 at both those two timings generally seemed to make the crop a little bit cleaner, and that there appeared to be a little bit of a dose response there as well. That was the disease data. What about the yields? Well, if we superimpose the yield on top of that, yield represented by the green boxes and the axes on the right-hand side now, you can see the untreated yielded around 7.7 tonnes per hectare. The SDHI azole clearly improved yield up to about 8.3, 8.4 tonnes. But note, the addition of Folpel, either at 0.75, a litre or a litre and a half, had a clear positive effect on yield, with that effect ranging from about 0.6 of a tonne per hectare up to about 0.9 of a tonne per hectare. So quite a significant increase. What did that mean in terms of margin over fungicide costs? Well, the blue bars here now represent margin over fungicide costs. The yields are the same yields that we have just seen. And in terms of the economics in this instance, we were seeing somewhere around 100 to 140 pound per hectare return on the investment in Folpel, depending on the rate used. Now, this was a high pressure situation. I actually don't think 2021 was particularly favourable for multi-sites or Folpet. I think it was actually a season that tested very good persistence of products, and it didn't actually, we would have expected to see larger benefits, but in this trial, that was clearly showing some positive and economic advantages with using Folpet, as we would expect. So in conclusion, where septoria is a problem, including Folpel, we find improves yield and margin over fungicide costs, so that's worth doing. And we think it's more effective than increasing the dose of the SDHI, not just because it's going to improve efficacy, but it also would be a better solution from a resistance management point of view. And it will be protecting both the SDHI azoles and the QII azoles, both of which are at risk of resistance development. In trials in the UK, the average yield response we've seen from 2 applications is around about 0.35 to 0.4 of a tonne per hectare. That's in high pressure septoria situations. It's possible in more resistant varieties in lower parts of the country, it might be a little less than that. But I think even where it is a little bit less than that, it is an economic addition to the programme and will help to slow that resistance development. Thank you very much.